we are back to our database management systems. I like the feedback you actually brought. Yes, the sound is good, but yes, I watched it myself and I realized that the interface was too faded, so you could not actually see. Yes, so as I promised you, we are actually going to improve it. So I hope you also send me feedback with regards to this one as well. Okay, right. So as I was talking about yesterday, I think we ended up with coming out with what a database is, and then what a database management systems is, and then the functions of database management systems, and also what the functions of the database. You understand? All right. So we realized that the database management system has a function, has an application that will actually help us to come out with the name of the data, and then the schema and the sub-schema. That is when we talk about the schema, it is the field names and also the real-time data that we would want to actually store into the various tables or various tables that we have. Okay, so today, before we move on to the various functionalities that are embedded in the application to enable us actually do the work, we want to look out for the old way of keeping our files and also link it up to the modern way of keeping our files. Okay, that's right. So the other aspect is file-oriented approach in data processing. Okay, file-oriented approach in data processing. That is the earliest system, the earliest computer system. Okay, now so the earliest business computer systems were used to process business records and produce information. So the computer systems that we have, the essence of even desktop, laptop, whatever we have, the essence of it is to use it to process what? Business records. When I talk about business records, remember, yesterday I told you another word for records is what? Values. Another name for values is what? A tuple. Okay, so records, values, and then a tuple, right? So I'm borrowing only business records. So I'm repeating again. This time I'm not going to put in the records, but I'm going to put in another concept, okay, or another term. Now, the earliest business computer systems were used to process business what? Tuples or values. You understand? And produce what? Information. So we use it to process business records, and then finally the essence of it all is to produce what? Information as and when we need it. But remember, it must store it. It must store it, alright? Before securely. I think we have learned about those things. They were generally faster and more accurate than equivalent manual system. It's a fact. You and I will bear witness that it is a fact that using the database management systems or using computer systems to process data were more accurate and manual. I think the essence of even Excel, if we should go to Excel, the history of Excel was the fact that a business student at Harvard University, I think you can go to the net, I'm giving you the gist, go and find the name for me. A business student at Harvard University was doing some trial balances or bookkeeping entries, and he realized that at the end of the day the trial balance goes to agree, and then when he is trying to investigate the records, you realize that you have to cancel. The guy has to cancel, and then so at the end of the day, all the jobs is like cancelled, and so forth before it agrees. So he was thinking of the fact that so why can't I even come out with a certain? Is there no way of coming out with an accounting software or a software that will help me to actually process the data, so that even if there are errors in there, I'll just delete the data and then put in a new one instead of using pen and pencil. You remember when we were old, in the olden time, we were using pen and pencil, and then before you were like, so he sought audience with one computer science student, Okay, he sought audience with one computer science student, and then they produce another form of Excel called VCalc. VCalc. Capital CAC. That is calculation, but VCalc. Okay, that was what they produced. And then, this VCalc, helped them to actually understand what they were doing, and then accurate reporting were also made and so forth. So you see, to coming out with a calculator. Spreadsheet is a form of a calculator. A calculator which is in the form of a sheet to support in the calculation and producing or processing of business records and producing accurate information was actually from the mindset of somebody called what? A business student. Go and find it for me. I've forgotten his name. It's been a long time, since 1996 I learned about him. So go and find it. His name, and then also the computer science students. They developed the VCalc. Okay, they developed the VCalc. Right. So you see, anything that is done electronically generates accurate report. And you and I, some of you are going to be auditors. Remember, when you go and audit any financial statement and they have actually cancelled them, some values have been cancelled. What do you think? What you think is that actually at Janokra you don't trust it. Why? So you don't believe it. You understand? That's right. So that is it. Okay. So when we finish with this, actually I'm going to post all of them to you. It is about 228 pages, but we are not going to exhaust all of them. We are only doing a bit, and then I'll move you straight away into. We are learning the concept, the elementary concept. We are not computer scientists, so not all of them will be relevant for you. Even though if you happen to be happy and you think you can use it, that's fine, fantastic. Read it for yourself or keep it. Somebody may need it, and then you can give to that person. Okay, but this is meant for business students. So if somebody is a computer scientist, it's not likely you'll be able to understand the terms in business. Okay. Now, so you see, so you see this idea of how could a program be used to produce accurate data or process accurate data and come out with accurate information. You see, the idea originated from who? The businessman, the business student. And then he sold the idea to who? The specialists. So hand in hand, they were able to come out with an information systems technology that was used to actually record and process data. So you see, you businessmen or business students, you have a lot to do. That is why we are introducing you into all this. You have to come out with idea. The programmers, the computer scientists are only there. They are there like a seamstress. Okay. You only have to go there with your materials. They have the skills to do it, but you have to go there and then tell them your style. You understand? Tell them your style. And then when you tell them the style, they use their skills to also do it for you. The same way, think about business. If you are a business student, think about how you can use information system technology to actually also come out with something new, novel. You understand? That is it. Alright, so that is that. So let's go on. Now. I've finished with the history of spreadsheet, and I've also come out with the point, the fact that you should be innovative. You should bring the idea, because when you make computer scientists run what can you say? What if we didn't help us on your mouth? When you are channel the person on your mouth, it's only what you want. You understand? But they are there. Put the idea in the bar, then they do it for you. Okay? We are not scientists. We are not computer scientists. So now, so they were faster. Computer systems were faster. Even they are still faster. Okay? These systems stored group of records. Group of what? Records in separate what? Files. Yesterday, you remember, we had records for students, we had records for courses, we have records for prerequisites, we have records for what do you call it? The results as well. Okay, that was used to process their diplomas and other certificates. Remember, so these are independent records, separate files. So student file, course file, prerequisite file, and then what again? Scores file. Alright, that is it. So separate file. And so they were called file processing system. They were called what? File processing system. In a typical file processing system, each department has its own files. So listen. So it means that students will go to the admission, and then course may go to maybe admission as well, and then may be passed on to the department. And then maybe we have prerequisite. It may also from department to admissions. So you see, they are sharing the idea, they are sharing it. But each person, each department is a data owner. But the matter is, a data owner, there is an unknown file not originating from the side. Just that it will be shared with another person, another department. But then for the concept, to say, all of them were sharing, having their own data processing files separately. Okay. Now, each department has its own file, designed specifically for those applications. Listen, for those applications. Application means software. Application means what again? Software. Tell me, I'm quiet. Okay. Application, software, and then programs. I think it's a yes, right. The department is working with the data processing staff. You see, with the department itself, only with data processing staff in relation to say student records, student files, and with department with your set of staff student data. Okay, and then you set your own policies and standard and for the format and maintenance of that file. That was the beginning. They issue computer systems, sanity, and as even manual sanity. Right? Now, programs are dependent on the files and vice versa. Programs are dependent on the The file. So they issue programs within software. Software are dependent on the files and vice versa. That is, when the physical format of the file is changed, the program also has to be changed. Physical format. Also, you will call entity relationship diagram very soon. But it seems I have to revisit some of them again. So the physical design, the physical outlook of the program, when the physical file changes, so that maybe we have decided changes. Maybe we said, I think yesterday we made mention of a database. Maybe this time around we are dealing with student records. But field names, the schema may be there 4 schemas. But as time goes on, we have realized that we have to add another schema onto another field name. So that's it. If you are father's name, you want to use it to collect the data of all the father's names of the students. It for the beginning. Say we need it. It means the physical design assistant. So as a subject, it means the program to suit that one. So I didn't originate from the physical, now you could run the program. It is from the physical, not program, not static. No, it doesn't work like that. Alright? Let's move on. Although the traditional file-oriented approach to information processing is still widely used today, it does have some very important disadvantages. You all know. Say the physical file, it has some disadvantages. Okay? So you see, this area is on 1.3, but for next Sunday the whole the PDF version, the 2 more units. Okay, right. But as I've told you, I am not going to do so much wasting time but we need to understand the theoretical aspect and then the concept underneath the design. Database management system is not something new. It is just a physical way of processing data, and we are migrating into what? Into computerized works environment. So that you don't need a store. Yes, still from. Yes, come in. Right. So we move on. We go on to database-oriented approach. Database-oriented approach to data management. So let's see how it works also here. Okay, database management. So 1.4. Okay, 1.4. Right. So database management approach. Now consider we are going to use an analogy. Okay, we are going to use what? An analogy. Okay, let me zoom it again so that you will see. You see, we are going to use an analogy. He said what? Consider database-oriented approach to data management. That is what we have here. So we are moving to understand it. He said, consider part of a savings bank enterprise. We've run, I wanted to use the student one. It's okay. You see the one I gave you, 5 files. The student one is okay. We are also picking another area of interrelated data. You understand? Which is the bank. What is the bank? And so we are going to see the type of interrelated data that we need to also use to process or to collect data and process and then come out with what? Information. So the first one was for university. Second one we are using is what? It's a bank. Right? So consider part of a savings bank enterprise. A savings bank, commercial bank, credit union, microfinance. All right? And then rural bank, they are all bank. So consider part of a savings bank enterprise that gives information about all customers and savings accounts. One way to keep the information on a computer is to store it, isn't it? Is to store it. Let me use my hand. Is to store it in an operating system file. Is to store it in what? An operating system file. Remember, operating system is not a software. Database management system is a different software. The operating system, as I told you yesterday, runs on the computer. Okay, so one of the operating systems commonly used now is called the Windows operating system. Listen, you may go on interview, they may ask you, what is the difference between an operating system and a software? Please, don't tell them they are the same. Operating system runs on the computer. Okay, it is the operating system that boots up the computer. I think you know all this. Okay, it's operating system that gives you music. It's operating system that shuts down the computer. It's operating system that has some programs, basic programs. You understand? To enable you run the computer successfully. So the fact that you buy a computer doesn't mean that you have finished the job. Some of you accountants, in fact, thank God they are going to an extinction. Some accountants from the Victorian age, 400 years ago, believe that they must buy the computer, and then once they buy the computer, they finish. Forgetting that the computer only comes with what? The operating systems. Okay, and some few softwares. You understand? Which is not business oriented. Alright? So, the software is the application that is going to be run on the operating system, on the computer, to do whatever you want to do. So the operating system is going to tell the software is going to tell the operating system what to do, what it wants him to do, or what it wants him to do. Okay. So one way to keep information on a computer is to store it in operating system file. One of them. So sometimes you can download some information, or you can store some information on the operating system file. It has given you a file. It has a space. Sometimes they are moving into a terabyte. Okay, megabyte, gigabyte. They are moving. So they have a space for you to store your information. Okay, the information that you want him to store. And then to also allow user to manipulate the information, the operating system. Okay, the operating system running on the computer system, you understand, it's only storing the information, but the software that is on it will also help you to manipulate the information. Okay, manipulate the information. The system has a number of application programs that manipulate the files. We are talking about the savings bank or the bank. Okay, so one of the files that the bank may want to keep, which is a program, is actually a program to debit or credit an account. You understand? You see, how do we debit the credit? How do we debit and credit an account? You have to open the T account. You understand? Two accounts must be in operation. One must be debited, one must be credited. Okay? In the physical realm. Now, in the programming realm, we need the software to debit and then credit. And this one, you and I don't have the skills. The skills we must have is to to have somebody who must have the idea, who are content, and also program and say you need a debit, you need a credit. Now debit and credit is either plus or minus. You see, into what you offer the debit or credit. Or also program everyone will say is either a plus or a minus in a certain account. Two, you need a program to add new accounts. When a new customer comes, or when a new activity comes, now see a different accounts. Find the BTECH account in another page. Spreadsheet, when you sheet 1, sheet 2, sheet 3, sheet 4, sheet 5, and so forth, isn't it? The same way on your paper, you must BTECH accounts, another account, because another activity, another business processing activity added one day, other page and we shall need to also employ a new person to also take over that job. Now, you can see a computer right here. It means we must have a program to enable us add new accounts. Database management system has it. Your computerized accounting software that you learn, you see, it enables you to create new accounts, to add new accounts. All right. Now, at the end of the second day, you have to also balance the books, isn't it? Balance the accounts. When the customer comes and wants to also know his account balance, if the customer wants to know his account balance, I think the debit and credit, the withdrawals and the savings must be reconciled, and then the accounts must come. You yourself will use paper and pen to calculate. You understand? And look at the inaccuracies, the mistakes and errors that may emerge from that area. Okay, that may emerge from that area. So this one too, you need to speak to the supplier. I mean the programmer. You understand? The programmer. That look, you must reconcile both the debit and the credit, and so the total of debit and total of credit must be reconciled to see whether there is a positive balance or negative balance for the customer or for the accounts. Okay, right. Now, a program to generate monthly statements, isn't it? You also will have to generate, maybe the customer will come, he will want to know his statements and the details of transactions that he has got. So, it means it means that we must actually automate. We must program the system in such a way that it is able to generate monthly statements. Okay? System programmers, listen carefully. System programmers write these application programs to meet the needs of the bank. Every organization there, no idea where they if we know among here gurus who understand the organization. Program and not fail over there. Over you shoot this and all programming you must be sitting down. Now what's you understand? You what's in the chain? Because joining heads together. Now what we are programming their mom. Now in this course, what we are going to do is introduce you clearly, because you are being trained as a domain expert. You are a domain expert between management and the programmers. We are experts kakra. Okay, you belong to management. But also you belong to the programmer. You collect from management and then you interpret the word management. And see, what a domain expert, you should understand the business. Now when you know what to do, how to connect here, because you should understand some programming languages and program terms. Okay? And that's how we don't know how to develop, not mistakes, not bugs. They come back in programming errors in coming out with the codes. Okay, now in the part you are wanting to show you can say they are the virus. Okay, but program and the other say a bugs, and the people who make mistake to be run said is will get back to the behind the scene. Not the papa share said program will code now yet thrown here. Because sometimes I come on. Sometimes upper or lower, caps. You understand? And our months are at the upper. Okay, so we get back to the user of a virus. To we the programmers, reference a box BUGS. Okay, so this will all write the application for the banks. New application programs are added to the system as the need arises. Okay, so that is it. For example, suppose that the savings bank decides to offer checks, current accounts. You see, credit savings, or sort of checks. And they said that the same day, I mean, more bank checking accounts there, it's like the same day you can withdraw the money, but savings account has also one time like a two. Okay. As a result, the bank creates a new permanent file that contains information about all the checking accounts maintained in the bank. Okay. It may have to write new application program to deal with that situation that do not arise in the savings account, such as overdrafts. Checking accounts there, overdraft room. Okay. Savings accounts, nobody will allow you to actually overdraw your accounts. Okay. As time goes by, the system requires more files and more application programs. Okay, so file processing system is supported by a conventional operating system. The system stores permanent records in various files, and it needs different application programs to extract those records and add records to appropriate files. Before the database management system came along, organizations usually stored information in such systems. So keeping organizational information in a file processing system has a number of major disadvantages. Data redundancies, redundancy and inconsistency, repeated data. Student records, we be store the data. You understand? We Kofi appear student records. We did some appear different department even and as a repeating in another department, in another department. No, the advantage there are redundancies. In fact, database design they call them repeated values, repeated records, repeated tuples. Okay, repeating and database management system here. Data must be recorded only once in a row, in a tuple, or in a value. So unlike yesterday, look at the student number now, Brown. Look at Brown. What's a Brown? Our records, tuple number 1 and a tuple number 2. And the other person, also the tuple number 1. Okay? So there were 2 records. What we say, database management system will not allow you. You understand? In fact, so we use a disadvantage on the old system, I don't know. But database management system will not allow you to record the same data even twice. Come on, you understand? But that was that data has been recorded already. You understand? It is data that it was recorded only once and also reflecting in other databases or other records. Okay? Okay. Now data redundancy and okay, so my right. So since different programmers create the files and application program over a long period, the various files are likely to have different formats, and the programs may be written in several programming languages. Programming languages. I had the accountants also introduce you. Programming languages. The church was code, educating programmers. In database management systems, one of the languages in the friend SQL, okay, sequential query languages, okay, sequential query languages, right. And now other usual connected to Fortran, the friend programming language like Fortran, but I think I'm not going to jam you with computer science languages. I myself am not a strong computer scientist. I am also a domain expert, but with a little bit of programming skills, not much. Okay, so we are only learning the concept, right? Okay, if you are not besides what programming language do you know? So that's it. What programming language do you know? I read as a file and as a programmer certain activity I say database management systems, yeah, and then you can also say SQL. Okay, SQL, right. Now, moreover, the same information may be duplicated in several files. That's duplication, redundancy. It can be redundancy, I don't know. Okay, for example, the address and telephone number of a particular customer may appear in a file that consists of savings account records and in a file that consists of checking accounts. No, it was said about people. You intend about pair. savings accounts. We have to link it. We just have to link savings accounts with that of what? The checking account, the current accounts. Don't say link it there. The data of the customer in the savings accounts. You know, link it there. The big Ghana for say, the cover one. Then by the click of a button, now records in the cover. Okay. This redundancy leads to higher storage access cost. So when you have data redundancy, repeated data go on one. Remember, it takes space. They take space in what? They never at the higher cost and at the ever. Okay, at the higher cost. So also talk more files, more hard drives and soft. External hard drives that has strong capacity. And also who predict that. So who predict that you struggle. Okay, yes. So this data redundancy leads to higher storage and access costs. In addition, it may lead to data inconsistency. Yes, inconsistencies. Data inconsistencies. You understand? Yes, because say repeated there, maybe it's not consistent. Say repeated over there, then it leads to inconsistent. That is various copies of the same data may no longer agree. For example, a change customer address may be reflected in savings accounts but not elsewhere in the system. You see, you're changing customer address, but in PWB, now say a invoice for command one. How do we know? It won't say you to supply their two baby. If you are all address for the man. It's answer the thing is not interrelated. No department get people need to know. We don't say everyone say you be updating video, but here has not been updated. And you don't want invoice and then security you go to ya, they are wrong address. We have first camera. Okay, so difficult in accessing data. Difficult. So air data I use redundancy so assessing of data is difficult. Assessing of data is difficult. Okay. So I am not actually going to talk much. Easy to read and understand. Right. Okay. So and then data isolation. We have data isolation, data integrity problems, and after consistency constraints. Meaning also atomicity, unique. Yes, unique. You can't say be atomic. Unique. See, a computer system, like any other mechanical or electrical device, is subject to failure. In many applications, it is crucial that if a failure occurs, the data is stored to the consistent state that existed prior to the failure. So, send your now city and also maintaining atomicity. The new point is as soon as a computer not crash, now you're saving your drive visual. You're saving over here. And we say accuracy no, but be a baby locating no. And as I say, hard drive no puna. Your person you need to locating was in chamber being a train. See a second, I was say a maintaining uniqueness, synchronicity and sound STA. Atomicity problem. Okay, so sometimes in a file system, no, say the message that was a change in address in customer and no more anchor and reflecting the same, it means that it has not maintained its atomicity. It's a individual information you are not no, you understand? Yeah, kind of I think say consistency constraints, integrity constraints, and data isolation with constraints. Meaning atomicity is the more reason why we need a database management systems. Okay. Now, so in many applications, it is crucial that if a failure occurs, the data be stored to the consistent state or be restored to the consistent state that existed prior to the failure. Consider a program to transfer $50 from A to B to account A to account B. If a system failure occurs, the execution of the program, or said if a system failure occurs during the execution of the program, it is possible that the 50 was removed from account A but not credited to account B. See, and then it's about inconsistency resulting in an inconsistency database state. So that clearly it is essential to database consistency to database consistency, that either both the credit and debit occur, or that neither occur at all. Neither occur at all. Okay? Yes. Either say ama, or either say nina abba at the same time. Debit and credit has occurred. That is, fund transfer must be atomic. Carefully, I will say a credit straight away. Next is atomicity. But atomicity and inconsistency. Okay? Right. Now, the same applies to Okodi Usika Bank, and as well ATM machine. What we do is can amount. We open was about one day two. Next time we call one day we say radiation. No, it is an error from the machine. Until we are there, one day they will call you. One day they will call you, investigation, and one day they will call you and tell you, say, what do you want? Okay, wrongly credited to you. Okay. Alright, so I think I don't think that can put me already. So I'm going down to at least have time to read anyway. Have time to read. So characteristics of database. I think yesterday we did it. So we don't need to. Yes, I think one thing we left in the characteristics or the function of the database is the concurrent use. Concurrent use means that several users can use the database, the data at the same time. You understand? That file, I put any data now. Many users can use it at different locations at different times, answering different questions from different users with the same base. That is the data. It's a central aspect of information systems. Such concurrent use of data increase the economy of a system. Yes, which is the same data can be accessed by Mr. A, Mr. B at Sunyane, Accra, London, and China or Far East. Let us say the economy, data economy, okay, and my young boka be brave. An example of concurrent use is a travel data. In fact, we were 1.5.1 this thing. We were 1.5.1. As I've told you, I'm not going to easy to read and understand. So we put permit to read in one way I won't read it. But the essence of the syllabus also both theory and practice into. That is why I am wasting time to tell you some of the terms that we use. Until you can say data concurrent use. It means that different people can use the data at a different time and different location, even at the same time at different location. Okay. So an example of a concurrent use is the travel database of a bigger travel agency. Some of you, I'm praying you grow, and then after coronavirus is gone, you'll be traveling and so forth. So when you are about to travel by air, you will have to go to the travel agent and then buy. Now, when you go to the travel agent, he's hooking himself to a software. He's using a software to sell tickets, okay, to customers. Now, this software is accessible to every travel agency across the globe. Okay, so as ticket agent number one is using it to book the ticket, another person is also using it to book it in Nigeria, another person is to the same location. You understand? Somebody is also booking it, but different airlines. Okay, somebody in Nigeria, assuming it is British Airways have got their numbers. So the one running in Ghana, you understand, will be using the same British Airways system, you understand, to book or to sell the ticket. Somebody will also be using the same British Airways system to sell the ticket. Somebody in abroad, in London, will be using it to sell the ticket. So you see, it's accessible, you understand, and then at the same time by different travel agencies. The employees of different branches can access the database concurrently and book journeys for their client. That's right. Each travel agent sees on his interface if there are still seats available for a specific journey or it is already full. So Ghana, never say Ghana, and abroad. You can see it coin. You don't have British Airways. We are complicated Thursday here. Thursday. We want to travel on Thursday. So we go to the travel agent. He looks at Thursday. You understand? Among for the whole across the country, we are turn ticket. Every travel travel agent is selling it. And you are not me up of course for those I got one passenger pay, and as I got 2 passengers, I got 3 passengers, and as a ticket in answer is easy. Why? Because the database the ticket system, it is a more so about doing now at the end of so because we can access it across the whole country or across the whole world, right? Okay, so structure and describe data. Fundamental feature of database approach is that the database system does not only contain the data but also the complete definition and description of this data. So you see, the schema, you understand, and the sub-schema. This description are basically details about the extent, the structure, the type, and the format of all data, and additionally the relationship between the data. That is going to lead us to another area after that is the practicals. This kind of stored data is called metadata. Another one. First, data about data. Listen carefully. See, he said these descriptions are basically details about the extent, the structure, the type, and the format of all data. You understand? And additionally, the relationship between the data and the various files. You understand? This kind of stored data is called what? Metadata. Data about what? Data. Right? Data about data. So we have schema, sub-schema. Okay, these are all the structure and the description of the data. It is the good one. Okay, the good one. It will define any relationship. Nothing about the metadata. Data about data. Definition, structure. Data about data takes the schema and the sub-schema. Okay, and any relationship that exists between them. Right? Separation of data and application. As described in the feature, I'm over 1.53, okay? 1.53 is here. But even in other mountain, you'll be able to know, right? Okay. As described in the feature, structured data. The structure of the database is described through metadata, schema and sub-schema, which is also stored in the database. An application software does not need any knowledge about the physical data storage like encoding, formatting, storage, release, etc. No, it only communicates with the management system of a database through a standardized interface with the help of a standardized language like SQL. And then the point to define the data and the structure. Okay, SQL, right? Or by a point to define the data and then what data should be kept there in every field. It is done by a language called what? SQL. Now the access to the data and the metadata is entirely done by the database management system. Now in this way, all the applications can be totally separated from the data. Therefore, database internal reorganization or improvement of efficiency do not have any influence on the application software. We are talking about data integrity. Data integrity is a byword for the quality and reliability of the data of a database system. In a broader sense, data integrity includes the protection of the data, the database itself, from unauthorized access, so enforcing of confidentiality and unauthorized changes. So data reflects facts of the real world database, right? So transaction. A transaction is a bundle of actions which are done within a database to bring it from one consistent state to a new consistent state. In between, the data are inevitable inconsistent. Inconsistent. A transaction is atomic, which means that it cannot be divided up any further. So my catch order that is atomic. It means repeating view. Say repeating it means it's no more maintaining its atomicity. Okay. Within a transaction, all or none of the actions need to be carried out. Doing only a part of the action will lead to inconsistency inconsistent database. Okay, right. So I'm also moving on gradually. I think if we are to read advantages, let's go to advantages. I mean, advantage. I think you can read advantages yourself. Okay, we don't need, but read it because I will ask you. I'll ask you. So read advantages yourself. Okay, I think these are all advantages from this area. Are all advantages. Okay, advantages. I think it may also have a disadvantage as well. Okay, but disadvantages. Despite the disadvantages, by all means, it has come to stay. Okay, but you try to work within the disadvantages, and then I mean, work your way. The fact that there is a disadvantage, it doesn't mean that actually you don't need to use database. Yes. As a car, car idea for accident, but comes in use. You didn't make a chocolate idea, so you did. You know, so many chocolate or a before so you are a big hospital, but the issue. But we need to work our way through. Okay, and I think the disadvantages are not difficult at all. Okay, so now instances and schemas. Database change over time as information is inserted and deleted. Okay, inserted. We insert data into the database. The collection of information stored in the database at a particular moment is called an instance. So Masaka Bakudium, the first saying instance, the Baku records, the Baku saying values, the Baku instance, the Baku tuple. But tuple, the program is in the use of tuple. Okay, and another name say information I store into the database. The friends say instances. In our first example, also in our student table, okay, student table, you have how many instances? Take the schema away, the structure. Take the structure and the definition away. Not for the soft schema, okay? Not for data of data, for. When you say you were only 2 records, and you look at there were 2 instances in table student. How many instances do we also have for the friend said, how many instances do we also have for what is it? Yes. How many instances do we have for this one? How many instances do we have for course? Course. No. Let's go to course. We have this. Alright, so we'll call slide. I think slide number 2 or 3. We'll say, let me zoom it for you to see. We're going to say we have I'm inside zoom. Right, so come on, alright. Okay, so let me zoom it again. Now you have the instances records, but instances now. Okay, so you see in the student records, we call this in the student records. In the student, this is the student table. This is the schema. Student name, student number, class. This is the schema. The sub schema is rich, and the student number is 17. The class is 100, or department what? Computer science. Brown, or the number is 18. Okay, the class or level 200, or what we call computer science. So how many records we have here? 2 and not 3, because this is the structure. This defines the structure of the database called students, or the file called what? Students. But real data, real life data is 2. It's your friend. How many records? 1. Your 2 records, because I Smith and Brown. And the same time, you can use the instances. At the same time, you can say tuples. At the same time, you can say values. That's what I did. Right. The same way, let's look at the course. How many? What is the schema? The schema is course name, course number, credit, and the department. Now, how many instances we have? About 4 instances in the water. And then we call prerequisite. We have the schema to be course number and then prerequisite number. Now, the details, the real-time data in Google Panel, a year, how many instances? This. How many values are there? 3. Okay, and both. Then we have sections. Every sections. Sections. So, how many schemas are there? 4. Is it 5? 5. How many sub-schemas? How many values do we have? We have about 5 values. How many instances? 5. How many records? 5. How many values? 5. I hope it's clear. Right. Then grade report. Grade report, we have student number, and then session session identification number, and then grade. So that is also here. How many instances do we have? We have about 5 of them. Okay, we have 5 of them. Now remember, they are not vertical. The instances are always in a row. Row 1, row 2, row 3, row 4, row 5. So how many data, how many information do we have, or data do we have over there? How many values? How many records? You have 5 records. How many records? 5 records. How many records? 5 records. How many records? 5 records. And then I had here students, we have what? 2 records. I think prerequisite here 3 records. Okay, and I think course name so 4 records. All right. So that is it. Okay. Okay. So we move back. Oh, come on. What is happening? Okay. Right. So the collection of information stored in the database at a particular moment is called what? An instance of the database. The overall design of the database is called the database schema. The overall design, okay? The schema, that's the structure. If you can say the table, the naming of the table, the structure of the table, and then related data and all the naming of the table, the structure of the table, the definition of the table, the field names, the friend name, schema. Okay, schema. So schemas are changed infrequently. Time change. But sometimes the time changing, this is the need arises. The need arises. The next say, if you are very critical, I also you change. Okay, so schemas are changed infrequently, if at all. But sometimes with this modern world, this time the name the concept of database. Go. Okay. Oh, come on, give me a go. Okay. So the concept of database schemas and instances can be understood by analogy to a program written in a programming language. A database schema corresponds to the variable declaration along the associated type definition in the program. I had a too technical. I don't want you to go there. Physical schema. Physical schema. Physical schema describe the database design at the physical level. Okay, physical level. While the logical schema describes the database design at the logical level. How do we get access to the database? Okay, we have the data at the Apple. The database also have several schemas at the view level called sub-schemas, sometimes called sub-what schemas, that describe different views of the database. Okay, different views of the database. Everything about the data types could be the sub-schemas. Okay. Alright, so I think database models. Now, as we were doing it, I think last time when we were doing it, I think we were on the modeling. Before we give the whole thing to the programmers to program, you understand, the vision and the way we want to do it. Remember the analogy of the savings bank accounts. You understand? We have structured or we have put up what we need to do so far as we go into the banking. We We need the savings accounts, we need the checking accounts, we need the customers accounts, we need any other schemes that may arise. That's what I'm saying. The schema we are okay, we don't change it, no problem with it a little bit, but no problem, it's okay. We only want to understand the concept, okay, the concept. So we move on. Now, underlying the structure of a database is the data model. Okay, now please hang on a bit. I want to check to see whether I'm not exhausting the time. Okay, I'm left with 5 minutes to exhaust 1 hour to the lecture. Okay, so let me continue. I will make sure I finish this. So underlying the structure of a database is the data model, a collection of conceptual tools for describing data relationship, data semantics, data consistency constraints. To illustrate the concept of a data model, we outline 2 data models in this section: the entity relationship model and relational model. Both provide a way to describe the design of a database at the logical level. At the what? Logical level. Remember, we have the physical level and the logical level. Right, I think I don't want to take risk, and so I'll end up here, and then next time we will continue from point 1.81. Okay, point 1.81. All right, so that is it.